So as I said, this is we go to do the matching 3D contour. So from here we can see the stress. This is a moment. MES is another direction. Okay. So from here we extracted out all the nodes. Actually, this is the nodal value. You can let's say the maximum nodes only, and then we can have a release nodes. So this is the information we can click. They can go to the point. That's the value. Each one they will navigate to that the contour. Actually, inside there is they got a node value or reference. Every node has a reference. Each node has 6 degrees of freedom. So you can click it. Okay, so this is a beam we're opening, and then I can show you the design without the detailing. So this is a detailing. So they provide the diagonal bar, and then top chord and bottom chord they design based on just now I mentioned a few criteria, the moment, shear force, tension, compressions. And this is a result diagram. Envelope. So everything is here. Okay, so now we have move on to the next. Okay, so this is a summary of the stress contour, contour force integration, object design. So you come to the individual object design and detailing isolatedly, an easy and practical application. This is a rough foundation. So rough foundation, at the moment they can do the column drop panel. We don't need to input another slab. You just define on this column what is the dimension of the drop. They will automatically do for you. So this is a rough contour. This is a stress contour in the MES. This is in the S direction. So S direction is a Z2. So you can see the negative moment, maximum is 215, and positive 700 over. So this is a report. So each one we actually compute, we check punching shear for you. Now actually we only lack of this detailing. Detailing will have some hard time to do it because this type of layout very easy to do the detailing, no problem. But when you're talking about the random column, the column simply lay without systematic. That's a difficult part to handle. A lot of software in the market, they say they can do the detailing for flat slab or rough foundation. Then you will follow another question. You see, how about if I column is randomly here and there, and how they do the determine the street? If you have, maybe you can provide us. We can maybe get some idea from it. So this is a seismic solver. So we have an example later I will show you. This one is a seismic solver. This one is based on linear time history, and we benchmark with the EPEPs. The result actually is based on the frequency mode, actually very close. Only when this frequency will become larger, there's a slightly difference. Okay, so now actually this is thing about linear time history. We compare for the two modes. So this is the accelerogram. So in Malaysia, we don't have this data. Even you ask the JKR, we don't have this data. So we managed to get from US those places that has happened in an earthquake many years ago. There's a record. But they do have some standard format. If Malaysia, we have that data with a slot in, they can run. It's talking about vibration per second. 1 second, they also divide in a very small segment. That's why you can see the graph. Then this When a shaping at the base of the effect, this one displacement pattern in the building. This means earlier on in Esteem 7, before Esteem 8, we also have a seismic, but it is talking about not a dynamic, it's a static. Static, they just apply the horizontal lock, like the notional lock, like the wing lock, push the building. But the magnitude will be very high. Notional lock we take about, based on the ES, 1.5% from the total design deadlock, 1.5%. But if you're talking about static seismic, they at least 10% or 15%. So this is a very heavy lateral load. But still, again, still talking about it's not a real seismic, because seismic is a shape at the base, based on the acceleration, the vibration. But the static of that is pushed on top. But maybe before the dynamic, with the discount technology, static one also acceptable. It's good enough. I believe if JKR requests some those building that as a seismic, I think static also enough, because they cannot provide the acceleration, the data, how we do it, also cannot do it. So normally, if a static also can be applied already. So we compare with the maximum rotation displacement. This one is a response spectrum method, the maximum point of displacement. Okay, so okay, so this also for benchmarking, just one column extend out to the 10 story. Okay, so this is the seismic animation. So this is the angle value. Pattern 1, pattern 2. But this one I amplify a lot, or else you can't see the difference. Linear timing speed. This one is too much. I put 200, maybe you can see it. This one is a per second. I amplified 200 times. I think also not so much, 20. This one, 3 seconds, 4 seconds, everything like that. You see, sometimes it's slow, sometimes. Just like the angle value is a simulation, it's not real, that's why you can see a very consistent. This one actually is not consistent, because we need to base on the acceleration. Sometimes they will stay there for a while and move back. Okay. So this is roughly is talking about this. And if you're talking about actually from here I can share the notes. Then I can click off the top. I think the top one is the most significant, the displacement pattern. This one need to lock for a while. That's why if you want to run the seismic for a large building, you need a very powerful computer. So at the moment, analysis part is done. Of course, in the later day, we still need to incorporate with the design and detailing. So this is a dead note. So this is the time running of how many seconds, 100 seconds, 1 hour. So how they move the displacement. So displacement in S direction, velocity. This one actually, from this graph down there got a lot of data we can get. So the velocity in S, everything is it based on the what is the time. Okay, so normally from here there is enough what we call that information for us to do the design. Even EPEX is out to this station analysis. Okay, so this is a seismic, it's already. Now we go to this last one. We are talking about Revit. So Revit actually is a very early version. We have done it here. Anybody know what is Revit or not? What is the purpose? Or already start using Revit structure or what? Synchronize with the design. So actually Revit is like this. Basically, like this is a modeling Esteem 8. This is a beam. Okay, we model as a beam. But this beam only Esteem 8. They know this is a beam. If E-Text, they don't know what is this. Look like beam, but they don't know this is a beam, this is a column. So that we need to convert this Esteem model go into here. This is a Revit structure from Autodesk. This means we need to have some standard to make it here. They will recognize the beam, this is a column. But if a Revit is recognize this is a beam, we need properties. They're talking about width, depth, or everything. And then other software who has synchronized with Revit, they can know this is a beam, like E-Text. Let's say your model is here already, then E-Text can open this. Or any like strap may be there. As long as they synchronize with the Revit, they can open it, even they can amend it. Let's say you change the size, then even they can go back here. Because these two can, this is a two-way direction here is a two-way direction. So what is the purpose? Especially for checking purpose. Currently, like, I don't know if this Revit is really happen like those ideas come out to the Revit. Actually, it's very perfect for architecture, everything, QS, all are linked together. But currently, because our structure, our engineer and architect is not like same family. Like it's like I do the thing, I throw to you, this is your responsibility to do the thing. They never feedback like that. This is like one party, they release a responsibility all to you. They don't have any two-way direction. But at least I can see now Singapore government, if you want to sell any software to their country, they're talking about BIA. That means your software must be at least synchronized with one other software. Either is Revit, you're talking about autonomy is Revit, but you may have synchronized with another general analysis purpose software like Tekla. If you can synchronize with Tekla, also can. That means that is many years. I think Tekla may be talking about in terms of history, maybe like Esteem talking about 16 years, 17 years. That Tekla maybe 30 years. If you can do that, also no problem. But you cannot just alone, because Singapore they apply the accuracy checker. You design a building, somebody will check your building whether it's safe or not. So then, how to check? Usually, if you submit the calculation so big like this, the engineer cannot check. This is no way to check. Usually, how they do? They will take your layout, they design another type, use their method. Then they compare the detailing, which one is more. Let's say beam number 1 is this one more than this one. Beam number 3 is the others design more than they sort together. That's why your client cannot complain, hey, your design too heavy, one cut cost, because cannot. Your cut cost and another checker cannot pass, also cannot cut. That's why there's two parties to come up with a different design. Later on you put it together. That's why even like subframe and continuous beam, if one design using continuous, the other one using subframe, both is heavy one sort together. You can imagine they also can test a very heavy design. So even talking about the foundation, one is elastic.